when I talked in last class, there are different levels of organization of the body, right? From smallest to largest. So smallest is the chemical level. Okay? So we'll talk about the chemical level or chemistry of life. Chemical level, if you go back to last class, includes the atoms. Smallest component of the body, atoms, right? So, atoms join together to form the elements. And yeah, elements are formed by molecules, that's right. Okay, then elements join together to form the matter. Okay. So if you see from the smallest to the largest, atoms, then elements, then matter. Now, matter is anything that occupies space and could be present in three forms: solid, liquid, and gas or gaseous form. Solid thing occupies space, you know that, right? Liquid also occupies space. Gas also, air also occupies space, right? We know that. When you blow the balloon, right? Gets bigger, right? Occupies space. So all those are matters. Solid things, liquid, as well as gases. Make sense? Because they occupy what? Space. Now, if you see the structure of an atom, it has subatomic particles. Subatomic particles. What are those subatomic particles? Are protons, neutrons, and electrons. Okay, so those are the subatomic particles. Those are the main subatomic particles in an atom. Okay. Have you heard these names? Protons, neutrons, electrons. Okay. So now, if you see the structure of an atom, atom has a nucleus and outer part is called the shell. So in the center you have a nucleus called the atomic nucleus, and outer part or layer is called the atomic shell. Okay. Oh. Yes. Now, if you see the nucleus of an atom, in the nucleus you have protons and neutrons. Protons and what? Neutrons in the nucleus. Make sense? And on the shell you have the electrons. Okay. So you see this is an atom and it has a nucleus. Nucleus contains what? Neutrons and protons. Okay. And on the shell you have what? Electrons. Okay. Protons carry positive charge. Protons are positive. Electrons are negative. Make sense? pp. Protons are what? Positive. And electrons are negative. Neutrons are neutral, n. Okay? In an atom, you have same number of protons, neutrons, electrons. So, this one, for example, has how many protons? I showed here? 2, right? 2 protons. And how many electrons? 2. Make sense? So 2 positive, 2 negative. That means what?
Satisfied.
They will cancel each other, right? So it's neutral. Same number of positive and negative. So all atoms are neutral. Atoms are what? Neutral. Because of same number of protons and electrons, positive and negative. Okay? If any atom has 5 protons, it has also 5 electrons. Okay? Neutrons don't carry any electrical charge, so but the number is also same. That is the atom. Now, another thing important is electrons orbit the nucleus like this, and circles, moving like this all the time. Electrons, okay? Protons and neutrons are sitting in the nucleus. So, electrons orbit the nucleus, around the nucleus. Proton and neutrons, we can measure the weight. We consider one proton or one neutron as 1 dalton, also called atomic mass unit, AMU. That is the weight of one proton or one neutron. Electrons are considered as weightless, no weight. Okay, weightless. Okay, so electrons are weightless, and proton and neutron has each proton and neutron 1 atomic mass unit, AMU or dalton. Now, you tell me the number of proton in an atom is called atomic number. Atomic number. Atomic number is the number of protons in that atom. So what is the atomic number of this atom? 2. Make sense? Because 2 protons. How many protons? That's the atomic number. Okay? Another thing is called atomic mass number. Yeah, that is protons plus neutrons. So what is the atomic mass number in this one? 4, right? Because 2 protons, 2 neutrons. So in this case, it is 4. Here in this case 2, in this case 2 plus 2. Now, I am giving the very basic, okay? Very basic. Okay. Now, this is what?
Shell.
Shell, right? And this is
Nucleus.
nucleus. Okay. Most of the atoms have more than 1 shells. For example, if I add more shells here, this is another shell, this is another shell, okay? So, atoms usually have more than 1 shells. And outermost shell is called the valence shell. Okay? So outermost shell is the valence shell. And the electron in the outermost shell is called valence electron. Very electrons could be in all these shells. The outermost one is the valence electron. Okay, so those are few things you need to know. Now let's go back again to the atom. This is another atom. It has 3 protons. So how many neutrons it should have? 3. Same number, right? So let me use another color. So 3 protons, 3 neutrons, and 3 what? Electrons. 1, 2, 3. Electrons are negative. Protons are positive. Okay. So this is neutral, right? Same number of positive and negative. Now, if I draw another atom here, okay, this one has 2 protons, so it should have 2 neutrons and 2 electrons. Okay. Okay. Now, this atom has 2 electrons, but 1 empty spot here. No electron is there, but there is a spot here for another electron. It can accept another electron. Okay. So now both are neutral, right? Because same number of positive and negative. So neutral. Now you tell me, when these 2 atoms will come close to each other, since this one has an empty spot, empty seat, what might happen, this 1 electron from here can jump there. So we'll leave this atom and we'll go to the valence shell of this atom. Okay? So if that happens, now this electron is here, this one has lost an electron, right? So this one has lost an electron. So how many electrons this one has now? 2. Make sense? But how many protons? 3. Make sense? So this will become positive because 1 positive more, right? So it is no more neutral. Is it clear? So it will become positively charged atom. Now you tell me this one. This one has how many positive? 2, right? And got 3 electrons. Is it clear? So negative is more in this one now, right? So this one will become what? Negatively charged. And when an atom, so I can say, when an atom loses electron, it becomes what? Positive or negative? Loses. Positive. Are you positive? Okay. Okay. So makes sense because negative is getting out, right? So it will become positive. And when an atom gains electron, it becomes negative. Is it clear? So now the process, this process is called ionization. Ionization.
Is that the one for oxidation or reduction?
Oxidation reduction are the different types of chemical reactions. So ionization. Okay. So the neutral atom becomes ion. When the atom gets electrical charge, it is called ion. Okay. Either positive or negative, doesn't matter. Electrical charge, it is ion. So this is positive ion, this is negative ion. Make sense? By ionization. Now what will happen next? This is positive now, this is negative. They will attract each other, right? So an attraction will occur between these two, and that is called the ionic bond. Ionic bond. So ionization, right, causes attraction, positive and negative. Is it clear? Make sense? Yes, no. Okay. So we know positive and negative, they attract each other, right? So that is the attraction or bond to form a molecule. So atoms will join together by that attraction to form what? Molecule. Make sense? We know hydrogen and oxygen together form water. Okay? Okay. So that is ionization, how atom becomes an ion. Now, again, okay, let's draw the atom. This one has 2 protons, 2 neutrons, 2 electrons. So this is neutral atom, right? Sometime what can happen, the number of neutron can decrease, go down, change. So if this happens, you see, in the nucleus, it has 2 protons, 1 neutron. Because this one has lost a neutron. The neutron is less than normal. In this case, this atom will be termed as an isotope. So when an atom loses neutron in the nucleus, it is termed as what? Isotope. Make sense? This is not normal. So, isotope. Sometime when isotope is formed, the balance in the nucleus is lost because the number of proton and neutron is different now, right? Not same. When they were same, there was a balance in the nucleus, okay? Now the balance is lost. Equilibrium is lost, okay? So that can cause what? Sometimes, not always, not all isotopes will do that. Sometimes an unrest can occur in the nucleus and that can emit radiation. And in this case, that isotope will be termed as what? Radioisotope. Have you heard that? Radioisotopes? Okay. So radioisotopes are the isotopes that release or emit what? Radiation. Power. Okay. And that radiation could be very harmful. If that is produced in the body, that can kill the cells of the body. Make sense? So radioisotopes can kill the normal cell of the body. It's very, powerful. So it is harmful. But now, we know how to use the radioisotopes for our good uses. For example, if you got a tumor, those are bad cells, right? Bad cells or cancer. So you have to kill those cells, right? So now we know how to use the radioisotope to kill those abnormal cells or bad cells in the body, okay? So we use radioisotope to do that, to treat the patients. Also, we use the radioisotope in radiology, like imaging techniques. Okay? So, because we know radioisotopes can penetrate the soft tissue. Okay? So, if you want to take picture from internal organs, radioisotopes can pass through the structures. So, we'll use a harmless way that will not cause harm. Anyway, so that's the isotope and radioisotope. Make sense? Okay. Another type of bond that is called covalent bond between the atoms. This is an atom, this is another atom. nucleus, electrons on the shell. These are the electrons. This one also has electrons. Okay, so sometime what happens when two atoms come close to each other, some of their electrons get attached to each other like this, physically, and form the bond that is called covalent bond. Yes, so now since they are attached to each other, these two electrons are attached to these two electrons, so two pairs of electrons, right, are being shared by both atoms. We say sharing, okay? So they become the part of both, and that is the covalent bond, by sharing some electrons in the valence shell, outermost shell. This type of bond is very strong. Strong bonds. Okay? If this is a nitrogen, this is another nitrogen, how many pairs of electrons are here? Two pairs, right? So you will see when we write chemical formula, in this case, I will write two lines, two dash. That means two pairs of electrons are being shared. Make sense? So that's how we use the number of.
Is that what we call
electrons.
double bond?
Yeah, double bond, yes. Okay. Another type of bond, so we have learned already two types of bonds. Remember, by ionization, one atom becomes what? Positive, right? And another becomes negative, and they attract each other, right? That is the ionic bond. And this one is another type of bond by sharing the electrons, some electrons. That is the covalent bond, right? The last one, another type of bond, weak bond. This is water molecule. Water formula is what? H2O. This is water, okay? H2O. This is another water molecule. H2O. This is another water molecule. H2O. Hydrogen is weakly positive and oxygen is weakly negative. So this is negative, positive, positive, negative, positive, positive. So what happens when water molecules come close to each other? The attraction occurs between the negative and positive. Negative oxygen and positive hydrogen. Make sense? But weak attraction, and that is called hydrogen bond. Hydrogen bonds, okay? So water molecules in your body is mainly water, remember, okay? Your body is mainly formed by water, and all water molecules inside the body are being attached to each other or attracted to each other, held together by the hydrogen bonds. Okay? 4 chemicals or elements form about 96% of your body mass: oxygen, carbon, hydrogen, nitrogen. CHON. CHON. Those are the elements form about 96% of your body mass. Other chemicals are also important, or elements like calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iron, and iron. These are although present in very small amount but very important. Calcium is very important for your body, you know that. Iron, just give me an example. What can happen if iron deficiency occurs? Very common. Anemia, right? Have you heard that? Iron deficiency anemia. Okay. Iodine is needed for thyroid hormone production. So just know that those are also important. Okay. So let's stop here. So if you go over these PowerPoints, you will find that I have already talked about all these things. Okay? So this part is done. Chemistry of life. Did anybody come late after I took the attendance?